Wow, you guys just like all put your heads up at the same time. That was super nice. I think we'll wait like 1 minute, or maybe we'll just get started. It's 5:16. I think I'm supposed to start at 5:15. Maybe I'll wait 1 more minute for some last minute people to show up, like that person who just walked in the door. Started. Hi, everybody. Thank you for coming. I really appreciate it. I'm here to chat with everybody about peer-to-peer code collaboration and actually the journey towards peer-to-peer alternatives to code collaboration. So to start off, my name's Abby. I'm a full-time contributor at Monatic, and I work on the Radical project, which is building a secure peer-to-peer network for code collaboration. So I do all things product, all things community, all things talking. So I'm excited to talk to you guys today about what we're building at Radical. But before I start talking about peer-to-peer collaboration, I'll probably start with code collaboration as it stands today. And so let's talk about code first, right? And so the basis of code collaboration really exists first on version control, right? So version control is, version control systems are the software tools that allow us as devs to manage changes to source code. And so a brief history of the evolution of version control systems. So we first started out with SCCS, which is Source Code Control System, I think. Very functional name, which was like a proprietary and like local solution to version control. And then throughout time, we actually saw the evolution of version control systems becoming open source, so moving from proprietary to open source tools. But then we also saw the shift to this client-server model, right? Which was inherently kind of centralized. And so the concept of only having a central single repository that developers could access at one time. So meaning people would have to check out code, so this is like with SVN, check out code, and then that piece of code would be locked to any other developer until that developer checked their changes back in. And so around 2005, developers were like, why does this need to happen like this? You know, we realized that we could actually have, every developer could have their own working copy of the entire source code and change history that they could push changes to continuously without having to check in or check out of a central repository. And so that was kind of like the emergence of the distributed version control. And so to back up this, I have a short story. So we all know Linus, the father of Linux kernel. And so Linus was actually developing the Linux kernel on this distributed version control system called BitKeeper. And so BitKeeper was free for open source projects, but closed source. And so Linus was using this because it was the best thing to serve the really distributed, nebulous development process of the Linux kernel. And so what happened was one day, a Linux kernel dev, being the free software vigilantes that they are, decided to reverse engineer the networking protocols of BitKeeper, in turn leading BitKeeper to inspite / the free license, giving Linus access to the BitKeeper product. And so in that and through that situation, you know, Git was born, right? So Linus then in turn developed Git, which is the basically distributed version control system that is like the de facto foundation for code collaboration that was developed by Linus specifically for the Linux kernel community. And so with the development of Git, we actually saw, specifically in like 2005, I think to 2008, like the rise of a bunch of other distributed version controls. So Mercurial, GNU Bazaar, Darks, and Fossil all joined the contingent of distributed version controls. And so this kind of evolution from centralized to distributed was a really big advancement in software development that did a lot of really great things for increasing the efficiency of how we were writing code together. So so what's great about Git? I'm going to focus on Git specifically. There's a lot of great things about other distributed version controls, but I feel like that's a whole nother presentation. So Git is great because it's fully distributed, right? So it allows users, as I said, not to work off of this central one working repository, but it actually allows them to work productively offline. So I can work locally, I can push changes continuously, and then I can just sync centrally when it's needed. And so this leads, without having to rely on a central server, for a more fast and efficient development process. So we don't need to sync with a central server all the time. I'm able to push my changes continuously, and these large nebulous distributed projects are able to kind of operate as every developer is just working off of their local working copies and then pulling in people's changes when they're developing. And so that has a really strong support for non-linear development, which Linux kernel is famous for, right? But the Git branch model is like really cheap and like really easy to merge. So it's much easier to create forks. It's much easier to, again, work on your own branches. And these working copies that we all have on our own machines kind of act as these remote backups for projects. So we have Git, which is great, right? But what goes on top of Git, right? So like if we are able to now manage changes in code, how do we collaborate on those changes? How do we share them? How do we communicate with other developers so we can actually collaborate instead of only working locally? And so the collaboration layers built on top of Git started with the OG mailing list, right? So this is still the de facto code collaboration method for the Linux kernel development, right? And so the mailing lists are really great for a lot of reasons because they're self-hosted, right? So you're not relying on any central server. It's still within the ethos of having distributed workflows. And developers can maintain their local working copies, just network them through another open protocol, which is email. And so this email layer gives us the networking, so we can now start collaborating, but then it also gives us identity. So now a developer's identity to other developers becomes their email address. And so this was really nice for, again, this bizarre style development in which everybody was maintaining their own branches and communicating patches and changes. And also Git patches were like designed to be communicated via email. So, but I don't know if you've ever tried to use a mailing list or have seen the Linux kernel mailing list. Maybe I should move. But it's super shitty to read and to manage. So obviously the usability with some of these like OG hacker solutions aren't really up to par. And so that's why we've seen, this the growth and the rise of hosted platforms like GitHub, GitLab, and SourceHut. So these hosted platforms are centrally hosted, meaning you're not really self-hosting your instances unless you're using like a self-hosted GitLab instance. And so the source code that you're working on and these copies that you're sharing and networking are actually networked on central servers and central repositories. And so they often follow this like software as a service model. And so the identity isn't an email address, but it's actually kind of this online identity. So your identity is like locked into these platforms, but it takes on this whole new concept of like what connections and what data is actually associated with that identity. So it creates this global networking layer that anybody can create a profile on and anybody can access, but anybody can find anybody as well. And that does a lot for accessibility and discoverability. But, of course, these hosted platforms are really walled gardens. So although they're built on open protocols and, of course, leaning on distributed version control systems, they build these like really unique user experiences and interfaces that give you all these new features, but are like usually closed source, like GitHub. So hosted platforms have obviously changed the game for code collaboration, like specifically GitHub. We all know, I'm sure all of us in this room have used GitHub at least once, but probably many times. I mean, I know I use it every day. And it's changed the game for like many good reasons, right? So it's made these protocols, these version control systems, like really easy to use, and these collaboration layers really easy to use because it's transferred, it's taken the standard as email lists and turned it into these like super rich web interfaces that we can look at, we can understand, and we can communicate with. Communicate through, sorry. But it's also created like a very accessible standard way of working. So like once you know how to contribute or use the GitHub UI, for example, you know how to contribute to any other project. So like what GitHub did was kind of break down the barriers for what it means to contribute to a project by making and giving everybody the ability to do it, which has been huge for the growth of free and open source software. And so on top of that, if anybody can communicate from anywhere in the world, really, you now have this like huge global community of developers who are all collaborating on software, whether it's in public repos or private repos, but everybody's building together. And so you have this whole social coding aspect that has become kind of this, now ephemeral layer that builds on top of like version control systems that incorporates profiles, stars, contribution graphs, and like follows that totally enhances the way that we develop software together. And then finally, on a more functional level, GitHub actually has enhanced our workflows, right? Because these things like PRs and how we manage issues are now able to be not just connected to the code, but also to the people. So we now have these new workflows that are so natural to how we collaborate on code that were entirely defined by how GitHub presented it to us. And so that's a really powerful thing, especially when you start getting into CI and code reviews. GitHub didn't just make collaboration easier, they introduced new means of collaboration. And so we see that everybody really likes this. This has done a lot for software development. So there's over 40 million developers on GitHub right now that have created over 44 million repositories in over 41 countries. That's pretty fucking massive. That's pretty unreal of how global this domain, this means of production has become. And it also has done a lot for free and open source. And we mean it. We mean this very wholeheartedly, right? GitHub has done so much for the growth of free and open source software across borders, across the world. So this year, 1.3 million first-time contributors joined GitHub and made their first contribution. That's huge, And over 350,000 GitHub users made over 5 million contributions to the top 1,000 projects on GitHub. This is not just because people want to code more, This is because the tools in which we are collaborating and coding are becoming easier and more accessible to people around the world. And so because of this, GitHub has now become the largest repository of free and open source code, not just code, but collaboration, right? This is where everything is happening. This is where it's hosted, and this is where people are going to get engaged with the free and open source community. So, as a quick reminder, is that Git, I think a lot of people forget this, is that Git is really nothing without, GitHub is really nothing without Git, right? GitHub is essentially, introducing all of these new collaboration things, but it's also making it easier for us to write code and usually write code and manage those changes through Git. But its non-Git features have really overtaken the developer experience. So as I said, these non-Git native UI features, these new enhanced workflows are absolutely overtaking and now sucking in developers because they're creating new means of collaboration, which are great because they're making everything more accessible and easier, but they're also inherently creating a closed garden built on open soil, right? And this is extremely similar to these other global platforms like Twitter and Facebook that we have seen capitalize off of the emergent digital communities and spaces that the early protocols, free and open protocols of the internet enabled. And so although GitHub is free, for open source companies, at the end of the day, it is still owned by a massive US corporation that is Microsoft. And so I kind of want to drop this decentralization, decentralize everything attitude, because I think it's silly to be only proposing an alternative based solely on an ideology, right? Like, of course, Microsoft owns GitHub, but also GitHub works, and it's done so much for the free and open source community, and also just like global software development. But what we're proposing, and what I want to talk about, in this presentation, is that there are actually like real issues with hosted platforms, and those issues right now are just like bubbling under the surface. Some people care about them, some people don't. But as we see software development like keep growing and rising as fast at a pace it is today, and our digital ecosystem is like ever transforming and trying to like encompass like the means that it's like eating the world, these issues are going to become critical points of failure if they're not solved. So we categorize these issues into 3 categories. So that being platform risk, vendor lock-in, and security risk. So platform risk really relates to the platform that you're using to host your code and to host your collaboration being owned by one corporation, which gives that company the ability to influence your user experience and manipulate it and control it in ways that you might not really know, right? So GitHub can terminate an account at any time, and they have been forced to by governments. They can ban entire countries, which they have, based off of US sanction laws. They can change their terms of service at any point in time without user consent. And they can also discriminate based on user behavior. For example, if a user has visited or downloaded a certain project or logged in from a certain location. These are all things that GitHub has done, right? And now people are starting to realize like how that's kind of messed up to ban developers from an entire country based off of political intentions that are not related to the software development at all. But it is the nature of a platform being owned by one corporation. So the second issue is vendor lock-in. And so this kind of touches on how GitHub has created this new means of collaboration, right? Is that these non-Git native social artifacts and collaboration artifacts like issues, comments, and reviews are entirely hosted on GitHub. So you can say, if GitHub went down, I'd still have my source code, I'd still have my change sets, because it's local, because Git is distributed and I'm always have my working copy. But like, what would happen if you lost your issues? What would happen if you lost your conversations that you're having around the PRs, around the the issues? Like, what would happen if you lost all of the actual collaboration that goes into code collaboration? It's not just about the code anymore, because what we've done is we've expanded on what code collaboration is, and that expansion, what we've used to extend, is now entirely defined and hosted on GitHub. And also that social network. So as I said, that global community of developers is just like the Facebook community, right? Like all of our means and our social connections as developers, as people building projects and building code and writing code, are all unique to and entirely hosted by GitHub. So your stars, your likes, your follows, your contribution graphs, what projects you're associated with. Again, entirely hosted by GitHub. And then finally, since GitHub is, a for-profit company and corporation, they also really like to introduce additional offerings that try to encompass the entire development experience. So once Microsoft acquired GitHub, they launched something called Github Actions, which is offering, CI servers so you can have a GitHub integrated into your entire development process. And so the growth of the offering just keeps introducing more vendor lock-in for different pieces of the process, but also more attack vectors. And so that kind of leads into the third issue, which is security risk. So we all kind of know this. I don't like, security shaming anybody, but if GitHub was compromised, every single user account and project would also be compromised, as well as what's shown in the UI. And that's a really important thing, because not only could you access, for example, all contexts of a private repo, but also you could have all these different attack vectors. And these are just 3 on this document that we have of 10. I just didn't want to overload everybody. But for example, if your commit signatures aren't verified locally and you're just relying on that green check in GitHub, A hacker could introduce commits into the source code that appear to be verified or signed by one of the maintainers because it's based on the UI. Code reviews which aren't signed, and people are starting to sign their reviews now because of this security risk, can be impersonated. So a hacker can impersonate a maintainer and improve pull requests. And then also changes to the actual source code, like pushes to master could appear to have succeeded, or a range of different things in which a hacker would manipulate the UI, to show a user something that they haven't. So, I think the point of this diving into these issues is because we have this belief that as more and more our digital world, our digital ecosystem relies on free and open source software. We believe that our dependence on centrally hosted platforms and corporations for the distribution of open source infrastructure is inherently unsustainable. If there are all these attack vectors and issues with hosted platforms, and our repository of free and open source software is only growing and only becoming more critical for the resilience of our digital ecosystem, how can we rely on a platform that's controlled by one corporation? And so that leads us to what our thought is, right? If we remember back to the beginning of the presentation, Git is inherently peer-to-peer. It's inherently distributed. We saw version control go from centralized client-server models to decentralized version control systems. And so this shows this concept of peer-to-peer, right? So we believe that peer-to-peer is a new hope in the fight against the centralized hosted platform empire. And that's because peer-to-peer means interacting without intermediaries, right? So without third parties. So peer-to-peer systems are ones that we don't have to rely on a central server to operate or to use. And so the coolest thing about peer-to-peer is really this concept of resilience, right? So peer-to-peer systems are economically resilient because they don't need to make a profit, and they can distribute the costs of operating or using a system across an entire network. They're politically resilient because they're not subject to the will of authorities, and they also can't be captured. And they're very technically resilient, right? Peer-to-peer systems are harder to attack because there's no central point of failure. So they're really hard to take down. The whole point is that they can survive the zombie apocalypse, right? So they have this robustness that makes them very technically resilient. And so this resilience really vibes with the free and open source values, right? That the free and open source movement was built off of. But they also really vibe with the needs of the Web3 community. In a domain in which we're building disruptive technology that is inherently combative to current systems, we need to be building resilient infrastructure that can resist or sustain in the resistance of central systems, of people trying to fight back. If corporations, if institutions, if governments want to take control, how do we keep them from doing that, right? And so we need resilient peer-to-peer infrastructure to secure and to ensure the health and the resilience of the free and open source ecosystem, but also the Web3 ecosystem. So on top of that, the peer-to-peer ecosystem is growing so fast. We're seeing not only peer-to-peer infrastructure, but also peer-to-peer applications and communities growing, and then all these blockchains are popping up everywhere. Peer-to-peer is where it's at right now, and the ecosystem has seen more development than it ever has before. And so a really good example of this that I want to dive into quickly to kind of define what peer-to-peer looks like in practice, and also talk about one that's really maintaining a lot of the peer-to-peer values is Secure Scuttlebutt, right? So SSB is a resilient peer-to-peer social network that gives us as people trying to connect and share pictures and messages with each other the ability to do so without a central server like Facebook or like Twitter. And so how SSB works is through this paradigm called a social overlay. So to ensure that I'm getting the data that I care about, that I'm interested in, what I do is me as a user, the protocol replicates data based off of my social graph. So basically my friends, who I follow, who I tell the protocol I want to follow. And so what the protocol does is it replicates not only my friends' data, but my friends' of friends' data. So I'm getting this replication graph that is resembling also like my social graph, so who I'm interested in and who I want to follow. The additional layer on this is all of these little nodes are backed by cryptographic peer identities. So it's not an online profile defined by a certain platform. You know, these are defined to my device or defined to me uniquely as a user, and they're backed by cryptographies. And advancements in networking cryptography have given us the ability to have this additional layer of security that centralized platforms aren't able to access. So SSB is great, and I know that I use it a lot, more than I did before, and I think it's being adopted in a lot of different sectors, which is really great. But we're also seeing still some challenges in peer-to-peer networks. And so the first one is like availability, right? So though peer-to-peer networks are always available, the data isn't always available, and this is because of the nature of this like new replication, paradigm that we're introducing. So there's problems with replication lag. I don't know if you've tried to open Patchwork after not opening it for a long time, but it takes a little bit. Eventual consistency and out-of-date content limit peer-to-peer networks' ability to maintain consistent and predictable availability of network artifacts, which is like a really important thing. On a peer-to-peer network, you need to have your data available. And the second one is usability, which kind of builds off of the data availability thing, but these protocols are able to work offline without reliance on servers, but the applications built on them lack the ability for users to kind of collaborate or connect on a global scale, right? And that's because these protocols are separate of the networks, and they lack the third challenge, which is this concept of global seamlessness. Because these networks are, again, existing as little instances, like little, they call it like the cozy web, like little communities that are connected to each other and replicating data based off of their networks. They lack the network effects of global platforms because they're built on these separate protocols. But peer-to-peer can really solve most of the problems with hosted platforms, right? So it solves platform risks because you don't have to trust intermediaries to use the network, and it can't be censored by a third party. So, Microsoft can't come in and just tell you to ban developers from an entire country, and that's like a really huge deal. It solves vendor lock-in because users own, control, and moderate their own data. And this is really cool because although there's an issue with global seamlessness in peer-to-peer networks, I'm also in control of the data that I'm disseminating and replicating across the network, and also what data I'm replicating on my own machine. And so this gives users control over their network instead of just relinquishing control to a central platform. And then finally, security risk, right? So this introduction of cryptographic peer identities, like no central servers to rely on, and really inherently like local first data that's built on and built up from the local user's machine, introduces this new layer of security that, as I said, like central platforms just can't access right now, and actually solves a lot of these security risks that we see when we're relying on platforms to deliver us closed source experiences that are hosted and controlled by one server. So, to return again to the beginning of this presentation, as with the rise of distributed version control, Git really did decentralize code collaboration, but then GitHub re-centralized it. And so as we see peer-to-peer tech evolve and advance, we start to see the unique functionality that hosted platforms deliver, like network effects, rich user interfaces, like community, displaced by peer-to-peer systems, because we have the ability to build usable and functional, robust networks that totally disrupt what centralized platforms built the entirety of their product on. So we ask the question, if peer-to-peer tech is evolving, and if code collaboration was inherently peer-to-peer in the first place, why can't we have peer-to-peer code collaboration now? So we want to talk about how we have peer-to-peer code collaboration. So to do that, we talk about peer-to-peer code collaboration in theory. We believe that a peer-to-peer code collaboration, peer-to-peer alternative for code collaboration must satisfy a certain set of requirements, right? So it must work offline and not require DNS or online portals to function. It must not require trust in a third party or intermediary to use. It must exceed current security standards set in place by mainstream platforms, because they're just not good enough right now. And it must meet the usability, meaning like responsiveness, functionality, user experience, that user interface that is just kind of the standard for code collaboration now. It must meet those standards that are set in place by hosted platforms. And then finally, it must be audible, transparent, and uncensorable. And of course, it must be free and open source software. So if we have these requirements in mind, how would we design peer-to-peer code collaboration in practice? And how are we at Radical doing so? So it all starts with Git. As you can tell, we really love Git. And that's because Git is actually such a great foundation for peer-to-peer replication, because it's offline first. So Git is inherently optimized for full replication, and it doesn't assume having an online server. It actually has networking built in, which a lot of people don't know. But this offline first quality means that Git gossips really well. It's also designed for the bazaar model, which is very similar to how peer-to-peer networks are structured and designed right now. And then finally, pack files, which is a more technical reason. But the way that data is stored in Git, changes in code are stored, are through these like really awesome things called pack files that make the protocol really fast and make syncing really fast. And so pack files are actually the reason why us at Radical keep the storage layer of Git instead of replacing it with something like IPFS, because Git is just really, really good for storing code. And so how would we replicate Git repos across the network? So again, we start with Git, right? So it stays the same. We still have this local working copy that we push changes to, but it's paired with a peer identity, which is based off of a cryptographic, like an ID, right? That is linked to my device key. So at the start, everything's the same. When we want to replicate it, what we do is we don't just replicate this local working copy, we actually create this like hidden replicated copy that not only includes the original change set, the original source code, but also the remotes, meaning other people's working copies of an original source code. We include the remotes, we include that data, and then we also include the remotes of the remotes. So just like in SSB, as you're replicating the friends and the friends of the friends, we're replicating the remotes and the remotes of the remotes. And then it's all still tied to the peer identities of the original authors of the code that's being replicated. And so what this does is it gives us a social overlay for Git, right? Just in the same way that SSB replicates data through friends and through your social graph, we're replicating through the social graph of the code. So of how people are taking the original source code, forking it, creating their own working copies, making changes, how people develop, code right now, right? The different branches, and everybody has their own change sets, and we're replicating that all together. So when you're disseminating data across a network, you're disseminating not just the original working copy of you, the user, but also everybody else's that's associated with it. And so to do that, we design this kind of object called projects, right? So if you want to publish a Git repo to a network, what you as the founder of this repo, the original author, does is initialize a project. And so what this means is that you're linking your original working copy, your original change set, to this unique metadata file that is not only links it to your peer identity, but introduces more actual metadata that can be associated with the project, which results in, you can see at the top up there, a project ID. And so this project ID gives you the ability to also have other information on the project, such as maintainer keys. So if you have multiple maintainers to a project, you can actually have those linked to the project metadata file, giving us, as someone viewing a project, the ability to not only verify the authorship of a repo or a project, but also the maintainers and also any contributors associated with the project, because contributors, when they contribute, also have their own signing key. So what you need to know from this is that projects which are replicated across the network not only just include the code, but include all these connections to different peer identities, which give the network the ability to verify the authenticity authenticity of the code, of the people writing the code, and how it's been replicated across the network. And so really what you do is you announce your changes, you push them to the network, and just using Git, like a Git fetch with that project ID, you're able to pull in that project, verify its metadata, verify that it's a project that you actually want to contribute to or use, and then replicate all of the source code. And then when you have the source code, you also have the remotes of the remotes, and you have all of this other, data, the social overlay of Git, also pulled in to your local machine, where then you can interact with it locally and offline. And so, in addition, to solve the global seamlessness issues that we were talking about before, you could introduce a global canonical layer that connects these projects and these users, the peers in the network, with each other. And so to do that, we propose a totally ordered, consensus-backed registry, which holds that canonical project metadata that I said that you initialize when you start a project and you publish it to the network, and it links them together. So this gives us the ability to have this global layer that, for example, GitHub has, the network effects, right? If I'm able to, you need this global layer because if I'm not able to search or discover a project that I want to contribute to, then what is the value of the network in the first place? And so this global canonical layer solves that for this code collaboration use case by connecting projects to each other, but also gives people the ability to have an audible and transparent way to verify, again, maintainership, project histories, and also like different contributions. So this adds this other security layer on top of the cryptographic peer identities. And so these components together really make up Radical. And so Radical is a secure peer-to-peer network for code collaboration. And so we called it Radical because 'tis the root of code collab. Radical is the foundation, just as Git is the foundation for current code collaboration. We want to keep building on that, be the first root that sprouts from the seed for peer-to-peer code collab. And so as I said, really the stack is building on top of Git, and so we're really just extending Git with peer-to-peer replication. So we don't replace the storage layer, we introduce a new networking layer on top, and it's a peer-to-peer replication layer that works just like SSB, designed a little bit differently, but has the same like social, replication paradigm, where we disseminate projects through a network and replicate them through remotes of remotes, and it's all tied together with a global project registry, which connects the canonical project metadata and gives us the ability to search and discover projects just like we would on GitHub. And so why is this cool? So this doesn't only, first it's peer-to-peer, right? So like inherently it's solving a lot of the issues with hosted platforms because it's giving us the ability to collaborate on code without trusting third parties or intermediaries. And we don't have to set up our own hosting, right? So it's kind of this out-of-the-box ability to share and network with other developers. But there's also like a lot of really new, nice things that having this peer-to-peer solution offers us, right? And so that's the ability to have everything be offline. So this Radical developer experience is inherently offline and local. So not just my source code, like my source code is not just the only thing that's local anymore, right? This gives us the ability to have our issues, our comments, our reviews, these collaboration layers, these new means of collaboration that hosted platforms have put in place. We take them and now we're able to make them local again. And we're able to interact with them local. So we make everything available. So if GitHub is down, it's not like you can't access your PRs or your issues, right? You have them and it's available offline without trusting or relying on a hosted platform. And then, as I said, it also introduces this new layer of security. So we have these secure peer identities, which are linked to projects and linked to code, but also all of these artifacts, again, these issues and these reviews and these PRs are all now cryptographically signed. So you can introduce security at different layers and introduce it at the different collaboration primitives. So it's not just like your commit signing anymore. You know what I mean? You're commit signing, but you're also signing issues. You're also signing reviews. And so you're introducing this layer of verification that, again, hosted platforms can't access right now because you're relying on them to show you the green check or to verify it for you. And as I said, it's just peer-to-peer. So now getting into the project registry, which again is this global seamless layer built on top of the peer-to-peer replication layer. So why do we need a totally ordered consensus-backed registry, aka a blockchain protocol? And so there's like 3 reasons. One of them is that it provides like strong consistency. So again, it like layers in with the peer-to-peer network and gives us the ability to ensure like more predictable and consistent availability of objects across the network, because you're linking them in a global way, not just in a peer-to-peer way. And then second, it provides a global seamlessness layer that peer-to-peer networks are lacking right now. It introduces discoverability and canonicity in a way that's necessary for code collaboration, because we need to have these open borders. We need to have these ways of accessing other people's code and other people's projects. And so this global seamlessness layer is really important, but it also gives us the ability to like verify at a global level. And so third, which I'm going to focus on, is this concept of like persistent and resilient sovereign identity. So if we talk about our identity on GitHub, so like what is our developer identity? This is one of our founders' GitHub profiles. Our identity is really defined by like UI components, right? It's our profile, it's our avatar picture, it's our handle, it's our follows, it's how many stars we have, it's projects that we're associated with, it's like how many contributions we have in the last year. Like, I don't know, like this is like such a means of like defining, you know, someone's experience or their work. But this identity, again, is all defined by a UI, a user interface, a closed garden that's taking in our data, delivering us, you know, a reputation. And that is now our identity. And more, this is becoming such an important part of our like real identity, like meat space identity. You know, this is how we communicate. This is how we work together. This is how we judge other people's work. This is how, you know, we find other people to work with. And so this idea of having like the free and open source developer identity hosted on a centrally hosted platform is a little bit unsustainable. And so what this global project registry does is gives us the ability to have a sovereign developer identity, to have something that is persistent and exists outside of a platform, outside of a user experience. And it's completely managed, controlled, and owned by me as my user. I'm able to retain and have that autonomy to manage how my data is spread across, you know, a network. And so building up from that identity, you can introduce some really cool attributes by introducing like sovereign collectives. So if you build organizational functionality on top of these trustless sovereign identities, you can start creating new ways to manage access control and ownership, you know, which are becoming, as we see free and open source projects becoming less of just, you know, a code repository and more of a movement and more of a community. You know, the ways that we interact as an organization or a community are so important and becoming extremely like the concept of governance and like transferring ownership and like how we actually manage a project as a maintainer is becoming like very core to how we, you know, thrive in a free and open source ecosystem. And so these sovereign collectives gives us new means to manage and new means to control these aspects of you know, free and open source communities that people kind of are struggling to do right now. And then third, it introduces this sustainable layer, right? So like having a global project registry enables interoperable value exchange. And so this completely opens up, you know, what it means to introduce sustainability into free and open source, into the free and open source ecosystem. Like, we know that this is an issue, that free and open source maintainers and contributors are underfunded and unsustained because the volunteer model that we have in place right now just like doesn't vibe with like capitalistic incentives, right? And so by introducing value exchange, like direct borderless peer-to-peer value exchange, you completely like open up what it means to create, like what it means to support commons-based peer production in free and open source software development. And that's like a really, really strong value prop that we're like heavily exploring with the introduction of this global project registry, is like, what does sustainability look like in Radical and how can we support it? So this is what we have now, and it's technically really great. You know, we want and believe that Radical provides a robust, usable, and functional alternative to code collaboration. But it doesn't really stop there. So like what we're doing right now is focusing on building a usable alternative to code collaboration. So this is a screenshot, and I was going to do a demo for you guys today, but I didn't think I have enough time. It provides us the ability to have like a front-end client that we can use just like we use GitHub. And so this is what we're building. It's called Upstream, and we're building this for Radical and for the Radical network, giving developers the ability to actually, collaborate like they do now on GitHub, just in a peer-to-peer way. So I think I'm over time already. So that's all I have. But this is the link to our discourse. We actually host most of our development conversations in the open. So you can actually hop in there to see what our developers are working on day to day and get more updates on what we're building and why. We're coming out with like more of a public timeline very soon. So be sure to follow us on Twitter, which is @radical_XYZ. And I have to hop into another talk right now that I'm late for. But you can follow me on Twitter or ping me on Telegram if you want to chat more. Thank you. Oh, wait, this is mine.
We have a presentation.
I sent in the USB. I don't have to put my laptop in the USB. HTML connector, right?